So welcome to the panel. Today we have three panelists. One is Suyuan Huang from Big AI Institute, and then one is Professor Ruigang Yang from Shanghai Jiaotong University. One is Peter, who just shared from XYZ Robotics. And we actually prepared a few questions. So maybe we can start with the first one. So I think this question is probably different. Everybody will have different answers. So what do you think is a word model to you? Just to have a definition.
Okay.
Anyone who wants to go first?
Okay, I will take a pitch at it because we had just had a discussion about a week ago at a workshop. Okay, so I think this term word model actually came from, if I can remember it, I first heard the word model from autonomous driving world, and so as far as autonomous driving is concerned, the word model is about predicting next frame. Given a sequence and predicting what the next image or what the next frame will be. So and also we have seen a lot of simulation work on Genesis, for example, and they are all about predicting what's going to be in the temporal domain. So for me, I think vaguely speaking, one model is basically a simulator. It simulates the way that everything works, from human behavior to physics to I think basically it basically involves basically the physics simulation. That's the way I see it.
Peter, do you have or yes, please. Go first.
Yeah, I guess probably everyone in your field has some interpretation. Like autonomous driving, definitely you care about driving part. I mean, for us, we care about the boxes. I feel there are some questions about whether it's possible or whether it's probably is whether it's possible. Like maybe also related to the next question, like how general can this world model be? Maybe if you want to really generalize to everything, that will be great. But I feel if you do things very generally, then nothing you can do not anything well. Like for the boxes, like can you imagine, like can a normal human imagine like those kind of boxes that may present in the factory or warehouses? I don't think so. Probably my comment is that the world model, I would say for the model to build or the data thing to build, it needs to be more focused. Some AI knows what to focus on, what's valuable than to build it. Not blindly build a world model because you don't know what to build, what to collect.
So more focused word model, sort of like an abstraction model. Yes, that's a great idea. Yeah, how about Suyuan?
Okay, so I think the word model is, from the formulation side, actually is pretty simple. So basically you have a state of the world, we call ST, and you can get the action and also the ST+1. So basically the word model is learning the transition of the world dynamics. But personally, I think currently the word model is pretty much too much used, because as we compare the word model with some like prediction model or dynamics model, I actually think the generalizability is the most significant feature of the word models. For example, if you're predicting or modeling a very constrained task, you can predict the state, you can predict the action pretty well. It'd be like 100% accuracy. But I don't think that can be like named as a word model. So to me, a word model not only means that we need to predict the state of the environments, the 3D physical world, we should obtain certain kind of superior generalizabilities. For example, we can have generalizabilities over periods, we can have a generalizability over things and some physical attributes, also maybe the action in a very abstract level. But I think only if you have a very generalizable model in certain perspectives, then your model can be called as a word model for the prediction, for the planning, and so on and so forth. Thanks.
So would you say the furniture stuff you want to, for example, condition on the human action to see what happens to the furniture and all our calculations? Would you say that belongs to a word model, or it's more a specific model, or everything is a word model, any dynamics, as long as it predicts the future in some meaningful way?
Yeah, it's kind of very vague for define the boundary of the task model and dynamics model and word model. But in your case, like assembling a furniture or similar specific tasks, the model needs to have certain kind of generalization. For example, the size of the object, and also some physical property like stiffness or the articulation patterns. The model needs to address this kind of perturbations of environments, and even in a task, it can be called a word model as long as it can deal with large generalizability scenarios in this task.
Yeah. Cool. Oh, hard to say. Yeah. Okay. Next. Here.
What data bottleneck needs to be solved to build towards the embodied AGI? I think this question is a little big, but maybe the better question is, when do you know you'll have enough data to do something, for example, right? So usually the current way I think is you get enough data, which is what most of the workshop is about, generate as much data as you want as possible, and then you train a model, and then eventually you'll know, hey, maybe this works. If it doesn't work, let's go get more data, right? So how do you specifically target getting more specific data? Is it just test and try, or is there some better way?
Let me go first.
Yeah.
Okay, I'll go first. So we discussed about data bottleneck a lot recently. Especially we know that we have a data pyramid, right?
Yeah.
The internet data and sim data and the real data. So currently for different kind of tasks, we have different settings or recipes for combining this data pyramid to get a better performance on tasks. And actually, I think we'll need more criteria for defining like when we really break the bottleneck. So for me, I think it's a fair comparison with the human performance. So basically, robotics people, we have done a lot of great tasks, but previously we don't compare a lot with the human performance. But I think we are entering an age that the robot can have more efficient and accurate task completion capabilities compared to human. So for me, if we are scaling up the internet data or sim data or real data, if the performance can really comparable with the humans or even like outperform the humans, I think the data is valuable, no matter it is sim or real. And another perspective is, I think the cost of data is and the cost of data is really matters. As I mentioned this morning, so we want to have more reconstruction or generated data to do the data or object generations. So we measure the cost, compare with like automatically generating data and then also annotating the data. So the data bottleneck may be also evaluated with the cost of how you like contribute to the data scaling up process. So that will be another term that we need to compare with different solutions for the embodied AGI.
Yeah.
Yeah.
So enough money to pay for data first, and then
Yeah.
human performance is the
That's right.
benchmark. Yes.
Okay, I guess I was thinking about this. So I guess if we have to answer this question, we probably have to define when can we claim that we have reached the AGI or embodied AGI? So what is the metric that calculates this embodied AI has reached the AGI? Okay. I've seen someone talking about like 80-80 or 90-90, so maybe perform 90% of a human task rather than human. So something in this line, but I don't think there's really a answer to that yet. I think without that answer, it's going to be very hard to really define what kind of data we need. So I think I'm really open to this. So when can we claim? First, maybe not even in the embodied world, just in the physics, just in the cyber world. So when we claim that we have a AGI from OpenAI or ChatGPT? I think that should be the first question to answer.
Yeah. That's a hard question by itself. Yes. How about Peter?
Yeah, so yeah, definitely this is a big question. And yeah, my big answer is if the AI can solve or can answer this question. So maybe not very broadly, but say today you are working on, yeah, for us it's the box picking. So if the AI can answer like right now for the current performance, what kind of data is missing? Like what kind of data that we should collect? I mean, that's the first step. And then the second step will be, hopefully there's some robot to execute that data collection and labeling. Okay, I don't think that's extremely hard, but just need to think in this way. I think, yeah, AGI or yeah, no matter how much you collect, there is always new data. Like the information in the world is ever changing. So you definitely want some AGI that's able to learn by itself. And very conceptually is, yeah, you want to have a viral loop. Okay, so the AI by itself know what's missing. It can improve by itself. It's sort of like mechanical world. Yeah, you want the tool, you make a tool, you make a small CNC, and then you try to build a bigger one, and then use the medium one to build the larger one. So something like that, so that it can grow by itself. Not human always intervening. That's not scalable to something called like very general AI. Right, so that's my answer.
Yeah. But you're saying if you're a Tesla, you have enough cars, then you can collect as much data if V12 works somewhat good enough, right?
Yeah, so I would say Tesla, yeah, like their self is very clever. Like they created the loop for the data flywheel for self-driving. But there are many kinds of different things not yet have this kind of loop. So yeah, creating that loop is very crucial. And I mean, if some AI can like this is more not just technical but also business case. Yeah, you need to figure out how to create that that way. I mean, figure out who will pay the cost and how to collect real data efficiently. Yeah.
I want to actually ask a question about VLA because that's sort of the thing right now, but maybe start with a yes and no answer. Do you believe VLA will, let's say, take over the whole robotics, or do you not? And then we can think about, like, if you think there are different architectures, or what's the fundamental issue with VLAs like that. Yeah, so let's start with the yes and no answer first from each person. This is not exactly the question, but just, will VLA solve robotics? That's the question.
My answer is no.
You?
No.
No?
Yeah.
How about Peter?
Sir, I didn't get the question clearly.
Do you think VLA will solve robotics? Yes or no?
I mean, by itself, maybe no, but yeah, you need to think about the larger picture. So, as I mentioned, the hardware is a harder problem. Yeah, your AI need to include that. I'm not sure if it's in VLA, some sort of AI to include that, and probably also doing some hybrid approach with some classic method. You don't necessarily need to throw away all the IK or the post estimation. You can use them if they are reliable.
That's it. So yeah, do you want to expand your answer?
So
Yeah, maybe it's-
maybe it's a yes or no question. I think it would be interesting to have a straw poll among the audience.
Okay, sure, let's do that.
Say and it's
Yes, people in support of VLA will solve robotics, please raise your hand. No, wow, okay.
One, okay, one.
One, okay, how about people no? Okay, 5, great,
So many of you are.
I'm sure. So, yeah, maybe for the panelists, what other architecture do you think is missing in the current formulation of VLAs? Or, yeah, yes.
Okay, so I'm not sure what is missing, but if you think about computer vision, there are many smaller models that we start with smaller models. We have a model for segmentation, we have a model for tracking, we have a model for detection, we have a model for classification, right? And we know those models very well, and we know how to train them, we know how to improve their performance, we know how to make useful product out of this. And based on those many years of knowledge, then there are ways to really combine them to have very big models that will allow them. So this is how I think the vision evolves. From smaller model to bigger and foundation models. In robotics, it seems that if we want to do VLA, it seems like that we want to we try to run without even being able to walk. So I think many of those actions, as simple as folding, many are doing this, I'm doing this myself. As simple as folding a piece of t-shirt, pick a box and throw it away. I think Peter saw that the sorting example, right? I think this is really what I've been with logistics for quite some time. I think what shows there compared to what I have seen, it's like slow motion there. Okay. So we don't know, even in some very constrained environment, we don't know how to do this well. Do this with high efficiency, good enough to replace human workers. And now we're trying to have a model that will do everything. I just think it's a little bit too fast for me. Maybe I'm old-fashioned, but that's the way how I see it.
Yeah, but that's the language model indeed did a lot, right? And VLMs already did a lot. So, yeah, so is robotics gonna happen that way?
Yeah, so we did a lot of VLA works, and I think a lot of people, especially the young generation of students, they are pretty much interested in the BI.
Yeah, it's very good for papers, I'm sure.
Yeah, but yeah, I'm very skeptical about whether BI will solve the final robotics problem. And there are 2 points. And the first point is, as Peter also mentioned, so the robotics is a very huge problem. So basically, you need to solve the hardware, you need to solve the control problem, you need to solve the multimodalities. So currently, the hardware models and also the control models, they're not solved by the BI, and I don't think in the near future they can be solved by the BI models. And we can see nowadays we have very good dancing and control and motion models for humanoid robots. They are not solved by BI, they are solved by reinforcement learning. And this is my first point. And not to say that you need to have more modalities of input, including the force input, the tactile input. So these modalities have very rich states. I'm not sure whether they can be eventually modeled by the large BI models. And the second reason is that I don't think that imitation learning, the supervised learning BI model can eventually achieve superhuman performance. So we have seen demos from the physical intelligence and from generalist AI. So basically, they are not only using the BI models for the task training and deployment. And thirdly, we are actually putting a lot of time, the entire time for other methods as a compensation. For example, the post-training method. For example, the BI models they can achieve like 80% of accuracy on certain tasks, and that's pretty good. But if you are using more modalities, you can get like 80 or 85%. And if you're continue using the online reinforcement learning to improve the models, maybe you can get 90 or 95%. Not to say that you need the model to have impedance control, you need the model to align with some human values, so that can be safe and trustworthy. So I think there are a lot of paradigms or techniques that can improve the behavior of the robot. So BI will be a very mainstream models, and they can do a lot of contribution to the embodied AGI. But I think we need to explore, and it's necessary to explore other models for as together to contribute to the embodied AGI.
Yeah. Sort of like my work where we just combine everything into a box and call each tool, right?
Yes.
I see. Yeah, I think I already know the answer. Peter wants to say, but he's actually he commented earlier, right?
Okay.
Slightly. Yeah. So I want to I guess I have more questions, but I feel I want to open up to the audience a little more. If anyone has a question for all or a few of the panelists, feel free to speak up, raise your hand. I'll come to you with a mic. Okay, yeah, please.
I have this first.
Thank you very much, dear professor. So do you think, because as we can see, UNet over the years refuses to die, so do you think UNet can still help us in like action hat prediction? Yeah.
Sorry, can you repeat somebody can repeat the question?
Okay, so basically, UNet stays strong in certain areas. So does such architecture or paradigm can be like transferred to like the one in VLA action hand? So apart from pixel-wise like segmentation or something, can be like augmented to help us further.
So like more signal, more sensing input, that kind of thing.
Yeah, maybe Sue can answer that one.
Okay, and so your question is UNet still capable of predicting action hand in terms of the AI models, right?
No, can UNet be extended or like part of it can augment the VOA or vision language model? So basically, how can we reutilize what remains in UNet?
Okay, so I think like some periods ago, we still see a lot of models that extend the VRM models to the VRA models. So basically, can still remain some UNet architectures in the model design. And the recent trend is that people are delving more into the like transformer head for the action decoding. So basically, they are expanding the original architectures in the LLM or VLM and use that as a backbone or base architectures of VLM models and also the task decoding. So I don't think the UNet should or will be a must for the VLM models, but I think the expansion is actually doable. It really depends on the base model or the foundation model, the original architectures.
Okay, thank you very much.
Yeah, I actually have a question for the panel. So, you know how this research nowadays has become pretty different from what it was, let's say, 10 years ago, where big tech companies and, let's say, government research agencies were not that involved in this endeavor. So, at this day and age, like with the available resources you have access to from different institutions in mind, what do you think the role of academia research versus company research versus government institution research should be now in this learning-centered robotics world?
Okay, so one thing I always tell my students is that try to find the unbeaten word, unbeaten bushes. Okay, I think it's very easy. It's very easy to download a piece of code from GitHub and change a few lines of code. Maybe change the head, add a layer, right? Change some parameters to beat the so-called results by maybe 0.1%. Okay, but that does not lead to anywhere in those days. So what I suggest to my students, and also that's also my own research philosophy, that don't do the easy path, and do the path that will make a name for yourself. Okay. One thing to make a name, I think, is that maybe you can change the parameters. I mean, change input settings. Right? Everybody is doing vision. Maybe I can do vision plus tactile. Maybe I can do vision plus maybe LiDAR or ultrasonic and different modalities. So be the first one to start a new data set that is very different than everything else. And then you could be remembered. And also, one question I really want to, I was very tempted to ask about Professor from UCSD is that how many cars do you need to train your VRM? And I don't know if he's still online. So don't ever compete with as a university professor or student. Don't ever compete on resources with big companies. You can never ever win, right? So that's my 2 cents. Do something that is small but maybe even niche. I think we as the academic community is very tolerant about some niche, right? If you want to do a company, don't work on some niche market. It's hard, but as a researcher, find your own niche. Try to be someone that if we talk about this problem, you will be the first 3 names that people mention. That's how you make a name for yourself. Okay, so that's my few thoughts.
So I think it's all about resources. In industry, we care about some resource intensive problems. For example, the scaling law and how the model can be trained using tons of or millions of billions of images and millions of sequences of VLA models. So in academia, the setting is quite different. So we don't have a lot of compute. We don't have that amount of data. So we need to focus on fundamental problems in this field. For example, today we are talking about embodied AGI and robotics, and there are still a lot of fundamental problems left for the academia to solve. As I mentioned, there are hardware design problem, material problem, and also modality understanding, for example, the force tactile, and we need to tackle the control problem, like the impedance control. And so these are all fundamental problems comes with the hardware settings, the embodiment, and also the actuators, the joints, they are all coupled together. I don't think this is the advantage of the industry. And in academia, we can focus on this shaped problem and with certain fundamental aspects, and the student can really dive very deep into these problems and leave your identities, as Professor Yang just mentioned. And in industry, it's better to focus on your advantage using more resources and to find out, to explore the scaling law, to do large scale deployment and large scale RL training. I think the advantage of academia and industry is pretty clear. As long as you have a very clear goal of what you really want to solve in the both sides. So understand and identify the goal of your current interest, and then you understand your position, what is your advantage, and then you can solve it in your a more comfortable way, and that can probably increasing the probability of making real contribution to the field. Thanks.
Yeah, thank you, Peter. Peter, did you hear what the question is?
I mean, I heard many questions. So the current question is about what academia can do. Is that right?
Versus the industry and the role of each.
Yeah, I think it's pretty hard, but I would say academia is still very good for you to explore some weird stuff, or I mean creative stuff, or at least for me, it's about learning what works and what doesn't, and something like yeah, when we do the tactile sensing, like force torque sensor by itself, it's fragile, it's hard to calibrate, that kind of things. You somehow need to have. I mean, it's very hard in the industry to do that kind of fundamental exploration, and also for encourage you to think. I would say at school, at least make sure you get good education. You train yourself to be able to learn by yourself. I think that's the thing. And I don't feel you. Maybe there's a way, but I don't know how to compete with industrial level of throwing large resources. But I think at least just prepare yourself, and then and also in AI world, sometimes it's not the. I mean, in AI world, you want to be clever. I mean, either AI or robotics right now, to be useful, like finding the scenario is more important than having a lot of resource. I mean, those big company, when training those models, they don't make money. I mean, it's the smaller one that utilize things or how to build will benefit from that. So you want to be clever and have more friends from different discipline, like how to use that for chemistry, for biotech, etc. Yeah, and then after you graduate, have your idea, have some prototype, ask venture capital to fundraise and scale.
Yes, great.
Yeah.
So do the niche market and specialize, find friends. Okay, we'll take one more question from the audience and the last question of the day, if anyone has a question. Yes.
Thank you for very interesting discussion. There was a question, do you believe in VLA? VLA is a very general solution, but my question is more about perception. Do you believe in end-to-end perception models like VLM and making decisions from this model by some other algorithm? Or do you believe in multiple small models, something for detection, something for semantic segmentation, something for something, and doing final action prediction via some third party model?
Okay. If you ask me, the answer, my preference is definitely the second one. I think the large language model is really like, to me, it's a super agent. It has extremely good reasoning capabilities. But unlike some of those smaller, more specific models for vision tasks, they don't have nearly as accuracy. When you have ChatGPT, give an image, ask to detect certain objects, you can do it, but it's not nearly as good as you. And so I would definitely use the second approach, that use the large language model as a orchestrator, as a director, and drive those smaller models, drive those smaller as the tools that use those smaller models to give maybe implicit or explicit results, and they use the large language models to provide further high-level reasoning. So the perception is done by smaller models. So the combination is done by large models. That's the way. At least if I were to do a product, that way. For research, that definitely is probably the best way to have some implicit representations. So I guess so that's my answer.
And so currently we still not have seen the sign of addressing very long-term robotics tasks with models. So I think in the current stage, I would still prefer some kind of hierarchical models. That means you have LM or VLM to serve as a planner. They can do the task decompositions and decompose the long-term task into certain primitive tasks and use the end-to-end model to finish the primitive skill. And another critical point is the current models, end-to-end model, is hard for them to do very good error corrections. So the planner, especially the VLM or LM, they can help the models to correct the errors from the executions. And there are some VLM model can recover from failures, but I don't think that's very robust and can extend to long-term actions. So if one day the long-term VLA models, they can recover from failures. I think that's the day they can really replace the hierarchical models. But currently, I would still take for the second option.
Is it my turn?
Yes.
I think I don't want to answer the question whether I believe, but I believe like a first principle. Like first principle is from, say, machine learning theory, engineering practice, and also the time, like as time goes by, the hardware will improve. So what do I mean by machine learning theory? I mean, the theory is roughly like when you have a harder problem, harder means the input output has a higher dimension, I think it's a VC dimension. I mean, how complex is your problem? If your problem is more complex, then you have the larger model. Okay, so I think end to end, like it depends on what end to what end. I feel your end to end probably is other people's inputs, maybe not completely end to end. And from the engineering practice is something like you want to break down the problem. Like if something is not related to the other, then you should have them separately, unless they are just correlated, then you put them together, right? So if not, if it's Markov model, then you separate in time. Yeah, so that will help your program your software to be smaller. So yeah, it's very similar to what VLA idea. So yeah, I feel just don't throw away the tools. So like things like 1+1. Okay, you don't need to train like the addition. You don't need to train LLM for that. It's very complicated and maybe it's not robust enough than what it can do in CPU like very quickly. Yeah. So and I think Grok, Elon Musk, like they say, yeah, they are trying to use have their LLM to use the tools. So imagine they want to design a rocket. I mean, it's very hard for LLM, VLA, whatever to know the fluid dynamics, all those kind of stuff. But we already have those kind of simulator. So there could be a way to just have the AI to control these smaller tools and make them useful. And you are building based on a higher platform than just do it all by yourself. I think it's hard. And yeah, in terms of time, I mean, if you go back to 1990, so you like Yang Li Kun have the CNN for the text detection. Maybe at that time, probably nobody will believe, but I mean, as times go by, yeah, at a certain time, it will be useful, and it, I mean, as hardware improve your complex, I mean, you can build more and more complex models, and I think it's a roadmap problem. So you map out from 1D, say text problem, and then 2D to image problem, and then video problem with time. Yeah, that kind of thing. And at a certain time, it will be solved, I think. All right, that's my answer.
Yes, thank you, Peter. So that's everything for today. Well, there's poster session right now, and we'll have an award ceremony at 5. There will be 4 awards: best paper, best poster, best open source, and best speaker. I'll see you guys then.